Hello students. So today we will do this problem. The problem is about to prove that if E and F are independent events, then so are the events E and F dash. That means if events E and F are given to be independent, then we need to prove E and F dash also independent. What are independent events? Recall, as in the last video also I have covered, if it is given if E and F are independent events, okay, this is given to us, then we can write probability of E intersection F same as P of E into P of F. This is given to us. Now we want to show that events E and F dash also independent. That means what to prove? To show E and F dash also independent. Okay, it implies we can show this P of E intersection F dash same as PE into PF dash. Okay, this we want to prove. So to prove this, first of all we will make a diagram so that you can see what actually we are doing. So I'm making Venn diagram over here, and this is the box. Okay, and I will give the names. Suppose this first is event E and the second is event F. Then obviously what is this part? This part, if I give the name, it would be E intersection F. Okay, without any doubt. And what is this? What is this part? If I shade this part with the black, this one is only E, and this part is only F. Okay, but if I give the names in terms of E and F, how to write this? It means this only E will be E intersection F complement, and similarly only F will be F intersection E complement. Okay, you can see this because F complement means whatever the region out of F complement. If I take the intersection of F complement with E, then I will get only E. Okay, I hope it's clear. Also, you can see from Venn diagram, you can see E intersection F dash and E intersection F are mutually exclusive events. Mutually exclusive events. Why they are mutually exclusive? Because mutually exclusive events means if intersection is a null set, then they will be mutually exclusive. If intersection is null set, then they will be mutually exclusive. And you can see only E and E intersection F. Okay, only E means this one and E intersection F. In that nothing is common, so they are mutually exclusive event. Okay, so it implies that as if I write P of E intersection F intersection E intersection F, this probability will be 0. Okay, because they are mutually exclusive events, then probability of this intersection this would be 0. Also, how can I write event E? Event E I can write like only E means E intersection F dash union E intersection F. Okay, E intersection F. So if I take the probability both side, probability of E same as probability of E intersection F dash union E intersection F. Okay, now what is the formula of probability of this formula? This basic formula, P of A union B is nothing, it is PA plus PB minus P of A intersection B. Now suppose this is your A and this is your B. Okay, this is your A and this is your B. So what is the probability of A union B? It would be PA plus PB minus P intersection B. But this is A and this is B. But probability of A intersection B is 0 given. So it implies P of E is nothing. It is P of E intersection F dash minus plus P of E intersection F. I hope this is clear. Okay, we are using this formula. Whenever your events are mutually exclusive, that time probability of union is nothing. It is probability of sum of the events. Okay, so from here what is probability of E intersection F dash? Okay, this I will shift other side, so we can write PE minus P of E intersection F. Now PE and P intersection F. So remember equation 1, they are independent event. It means probability of E intersection F is nothing. It is PE into PF. Now you can see from both the terms, this term, PE is common. Then 1 minus PF we are getting. PE and 1 minus PF means probability of F complement. Why? Because PF plus PF dash always 1. Probability of any event plus probability of complement always equals to 1. It implies that E and F dash also independent events. Okay, you can also remember as a result. Okay, as a result, if E and F are independent, then first one in this question we have proved E and F dash are independent. Okay, this we have proved just now. Also, if I say E dash and F are independent, this is also correct. Number third point, E dash and F dash are also independent. Okay, so these results you should remember. These are important to solve numerical questions. Thank you.